Hello everyone. Let's go over some possible solutions for the practice final. On Monday, we went over the brief workflow on how the exam will work. It's the same as the midterm. We gave some small setup hints on the practice final, and hopefully folks gave it a shot because today we're going to go over a couple possible solutions for some of the questions. Looking ahead in the class, next week is finals week. There is Memorial Day on the 26th, and our final is on Friday, 1 p.m. to 3:50 p.m. It was brought to my attention by the dean that the college made a mistake in scheduling this time slot. This is only applicable for folks who are walking the graduation ceremony. So if folks are walking, let me see when it is. So Cabrillo graduation. But basically, the college set up the schedule and had a small conflict for some classes. In particular, the graduation ceremony is on the 30th. And I think this might conflict with some folks. So please let me know if you are walking on the ceremony. If so, then we're going to have to reschedule the exam for you. It's going to have to be an earlier time. So yeah, please let me know. I'm going to send an announcement later to see if anyone needs that. Okay, so yeah, that's about it. Next week is finals week. I'm going to have some office hours allocated somewhere around here. So I'll update this over the weekend. I'm just going to fill in some blanks and put in my different office hours. However, you can also contact me for an appointment. So if none of the times work out, feel free to let me know. I'd be happy to meet on Zoom, in person. Right, pretty much just let me know like the day before, and we can be super flexible. Okay, let's jump into the rest of the practice final. So I have it loaded up here already in my other tab. All right, so here we are. So yeah, we went through most of these questions and helped folks get set up with it. So let me go to this Jupyter lab. Basically, all we really did was set folks up with some test cases. So going down here, there's a bunch of commented out test cases. I was pretty much invoking a function that isn't implemented yet. So these first two lines are attempting to call a function that really isn't implemented yet. So yeah, that's where we left off at. Please see the previous recording to get caught up on this, in case you don't know where these came from. Okay, let's start off with the first question. So I'm going to comment out most of this stuff right here and just start from the very beginning. So let me highlight all of this. And once again, you can comment it with Control//. So that will comment out a whole block of code. Okay, we're going to start off with this first question, the list filter. Let me pull these side by side. Okay, here we are. Cool, so the goal of this function is to filter a list based off some threshold. This is a filtering algorithm. You should look at the looping algorithms to get a refresher on this. Well, once again, I'm just going to go back to the lesson 17. There was a section on filtering. So yeah, we pretty much already did this, but it's a different style now. Okay, so let me navigate back here. Where's that? Final exam. Okay, there it is. There are so many different approaches we can do to solve this function. I'm going to go through a couple of them. The the way that we're probably familiar with it is by creating an empty list and then populating it within a loop. Meaning we'll write a loop that goes through the original list and then look for numbers that are less than the limit. If the number is less than the limit, then we'll just append it to the output. That's the filtering algorithm. We're creating a brand new sequence from an original one. Okay, so let's do that. All right, let me write a loop that goes through the original sequence. So for number in number list, there we go. Go through the original sequence. We need to append numbers based off some criteria. The criteria in this case is if that number is less than the limit. Right here, that's what it says in the question. Returns numbers that are less than or equal to this. So let me modify this docstring. The limit filter with less than equals. Okay, so let's implement that criteria, right? We need to say if it's less than or equal to the limit, right? So if the number is less than or equal to the limit, then we just append it to the output. So output.append number. All right, once again, please be careful for the indents. Use 4 spaces or a tab, or Jupyter Notebook should do it automatically if your syntax was right. Okay, cool. So there's our list filter. Let's load this function into the kernel. Okay, I just pressed play. So it's loaded in. Oh, you know what? I forgot to run the very first cell here. My bad. This very first cell will let the checker work. The checker on the very bottom of the notebook. I forgot to run this. So let me run this. Boom. Okay. And now run the solution cell. Okay. Before we use a checker, let's test locally. I wrote a couple test cases here from a couple days ago. In particular, this first print statement is saying, hey, list filter, I need another list. So the argument inside will be another list because this function is returning a list. Hopefully it returns us the right result. The result should be numbers that are less than 5. So it should print, it should return 4.2 and 1.4. Right, that's what the function should return. And then the print statement will print that list for us. Okay, let me run this. So control enter, there we go. Right, here's our print statements, 4.2 and 1.4. Yeah, looks good. We have another test case here as well on the second line of this test cell. The only difference is the limit. The limit here is 10, meaning that we should have more numbers. 6.9, 4.2, 1.4, right? We should have an additional number. So let me run this. Control enter, there we go. Cool, so we're testing locally. It looks like our function is working. Okay. It might be good to check the checker now. Basically, this is not as verbose, but it'll be super small feedback. Okay, it's saying list filter. Cool, we passed everything, meaning that we're probably good. Right, once again, the checker won't really check everything. It's still possible for your solution to still be wrong, and the list filter will say it's right. But yeah, this is just bare minimal feedback. So yeah, if once you feel like you're ready to submit, it's the same as the midterm. Just for redundancy, we're gonna copy this function and paste it into the canvas. Copy, and then into the canvas, and then let me pre-format this. Paste. Oh, I guess that pre-format didn't do anything. So yeah, I'm just gonna paste it into there. So there you go, paste it. Let me make it bigger actually. I don't really like how the text is wrapping different lines. Cool, I pasted it in. And yeah, there is a redundant solution. This is here just in case folks lose their work. If you can, just go ahead and pre-format all of this. It'll make the font a little neater. So you can highlight everything and then press pre-format. Highlight everything, and yeah, it puts it in a nicer font. It's a fixed width font, meaning all of the letters are the same width. Okay, cool. So we just finished the first one. There are multiple types, multiple approaches that we can do. Right? This is just one that we're familiar with. In a future class, you might find yourself doing something called list comprehension. This is actually really cool stuff. So check this out. This is actually some really cool stuff. So I'm going to comment all of this stuff out. It's actually possible to do all of this in one line using a technique called list comprehension. So I'm just going to comment that out. This is list comprehension. We didn't really cover this in class, but you'll see this if you take the next Python class. So list comprehension is kind of a shortcut on building lists. Like, all we have to do is return a list. Right? See, this is an empty list. We just need to populate the inside with something. So here's a cool part. We can pretty much write something like saying the list will contain a bunch of number, right, for number in number list. Okay, so this is a little hard to read right now. Pretty much what this is saying is, it's saying for every number in the number list, put that number in the list. Right, so this is gonna pretty much return the same exact thing, but we can put a criteria here. Right? Only put the number in if that number is less than the limit, less than or equal to the limit. Right, so this is the list comprehension. We didn't really cover in class, but you could do some further research into it, and it's some pretty cool stuff. It's some really nice shortcuts. Okay, so let me load this in. So Control Enter. Okay, there we go. Okay, let me retest it. Hopefully it gives us the same results. So Control Enter, and yeah, it gave us the same results. So yeah, that's list comprehension. Okay. Cool. Unfortunately, I don't think this is gonna work in the checker because it's gonna say something right here. Let's see, syntax. Our solution doesn't use syntax that's required. But basically, the checker is kind of enforcing that we're using concepts we used in class. So yeah, so it's not gonna work for this case. Yeah, hopefully people can kind of see how you might use this in the future. There's a lot of different approaches we can do. So let me use this original approach that we're more familiar with. All right, people cool with this so far? Okay. Okay, let's move on to the next question. The next one is file sums. Okay. All right, file sums. We already set this up a couple days ago. So if you didn't watch the previous recording, please do. Okay. The goal of this function was to assume there's a file. And the function would read that file and tell us if the sum of the first four numbers is greater than 100. Right, it'll return a Boolean. So we already have this set up down here somewhere. Yeah, we have some test cases here. Okay, let me comment these out because we're done with the list filter. Okay. Yeah, we left off at setting folks up with a hypothetical test case. We set up two files. Right? One file that contained 4 big numbers, another file that contains 4 small numbers. So let me bring it up over here. You see these two txt files. Basically, our big numbers is right here. Let me split screen this. See, that's our big numbers, and then our small numbers is right over here to the right. So yeah, this first print statement, file sums, and if we pass in the file, it should return true because the sum of all of these are greater than 100. And in the next one, this should return false because these don't exceed 100. And so yeah, the function is returning a value, and then we're going to print that value. Okay, let's go to the function then. I'll pull these side by side again. Cool, so we have the function set up here. It just commented out. All we really left off with was a skeleton of a function that always returns false. Okay, all we need to do now is open up that file and start counting things. Hopefully people took a look at a previous lab for this. In particular, the previous lab was on a file input and output. Somewhere over here. Right here, lab 13. So yeah, make sure you take a look at this because we did this pretty much the same exact question, but a different variation. Yeah, right over here. Lab 13, files, and then right here, summing values. Yeah, it's pretty much the same thing. Okay, so back to the exam. We just need to open up that file. So let's do that, right? Let's go ahead and open that file. So open the file. We're representing it here as file name. Our file name is the string that represents the path to the file. So open file name, and you don't really need this second argument. I'm going to use it here anyways. It's R, right? Meaning we're opening it in read-only mode. We don't really need it because the default behavior is read-only mode, but I'm going to put it in there for readability. Okay, this function returns some pointer that gives us access to that file window. Right? I'm going to call this file handle. You can call it whatever you want. This file handle represents like a pointer to the open file. Okay, we're going to use that pointer to pretty much read each line, right? Read 4 lines. As a good programming practice, make sure we close for every open. So I'm going to go ahead and close it right away. This way we don't have too many open windows at once. Okay, so all we got to do is start reading lines in between. We're going to go through a couple approaches. The one approach that we're probably familiar with is reading lines over and over again. Like we could do something like a file handle.readLine. You might remember this from a bit ago. This kind of seeks through the file, right? It steps through the file. So this is going to return us the very first line. So I'm going to store this into a string called line1. And once again, this is a class function that returns a string. Okay, and you can look at documentation for this too. Like, yeah, you can just look it up on the Python documentation. It pretty much tells you what this function is doing. Okay, yeah, so this is going to read the first line, and we just need to read the next lines. So line 2 is equal to file.readLine. Line 3. And then line 4. Cool. So this is just grabbing every single line and storing it in 4 different string variables. All we have to do now is add them up. We just got to add up these variables and then branch based off of the sum. If the sum is greater than 100, return true, else false. So yeah, let's go ahead and add them all up. So we're done reading the whole file. We can assume this file has 4 numbers. So yeah, you can make this assumption. It makes the problem a lot easier. Okay, so let's go ahead and add them up. So down here, it's going to do something. We're going to add them up, like make a variable that's equal to the sum. We do have to convert these strings to a number, though. Otherwise, we'll end up with string concatenation, where if you add, if you do something like this right here, let me load up a Python terminal. If we do something like 1 plus 1 in the string, right, gives us 1, 1. So that's called string concatenation. We basically need to convert them to numbers. In this case, I'm going to use a float so we can support decimals. Right, this should give us 2. Okay, so let's go ahead and apply that conversion. So total is equal to a float line 1 plus float line 2 float 3 line 4. Okay, cool. So that grabs a total. Now we just need to branch off that number. Right? If it exceeds 100, if the total is greater than 100, then we're just going to return true, else return false. Okay, hope that makes sense so far. So let me test this. You know what? We actually did too much without testing. For starters, it might have been better to sanity check things along the way, like maybe sanity checking the total variable, right? Like before we move on to these branches, it might be a good programming practice to print the total out and make sure that we're calculating it correctly. But yeah, I'm just going to move on from here. So let me load in this function. So press play. Okay, there it is. Let's go ahead and test it locally. So this should print true and then false. All right, let's see. Cool, prints true and false. Yeah, that makes sense. Let's test the checker. Sweet, looks good. Pass, pass, pass. Meaning we're probably ready to submit this. This is just one possible solution, by the way, guys. There's a lot cleaner way to do this. The reason why I decided to go this approach is because I think it's more readable. But there's multiple things we can kind of make look cleaner. So here, let me paste this first into the canvas. So copy, and then paste over here. And let me convert it to pre-formatted so it's a nicer font. Okay. Let's do some optimization. Let's see. Well, first, this last branch can actually be represented in one single line. You don't really need to branch, like if total is greater than 100, return true, else return false. You can actually just return the value from this condition. This condition will return true or false anyways. So all we really need to do is get rid of these and just say return total greater than 100. All right, this is because total greater than 100 returns a Boolean. Right? This is a operation, and yeah, if it's true, we're just going to return true. Yeah, that's a lot cleaner. Another thing we can kind of clean up here is these repetitive read lines. It's probably, for this intro class, this is fine, but it won't be sufficient for a future class. A future class will be using arbitrary length files. For this class, right, we're assuming that the file will have 4 numbers. Right, so in another context, I'm kind of doing a different problem now, right? Like it can be possible to have a variable length file, right? Like maybe the file could have thousands of lines in there, or maybe it could have millions. So in that case, this assumption wouldn't really work. Once again, we're steering a tiny bit away from the problem. Right? I'm trying to introduce folks to a future test cases. Might be a better programming practice to loop these statements. And we know one way that we've seen is to kind of loop through the file handle. Right? If we were to write a for loop that goes through the file handle, you might remember that it goes through every line. So let me pull up an old lab real quick. I mean, old lesson. So back to the for loops in lesson 15. You might have remembered that we can iterate through a file handle, and this will return us a sequence of lines. Okay, so let's go ahead and apply that. Okay, so back to the exam. But basically, we don't really need to have these four statements anymore. Right? We can just write a loop that goes through the file handle. Right? For line in file handle. Right? The file handle is a sequence of lines, and line is each of those elements. Okay, so all we gotta do now is accumulate the total. So I'm gonna get rid of this accumulation step at the second to last one, because it's probably gonna be, we're gonna accumulate it inside of the loop instead. Meaning that we'll start total at 0. And then for every line, we're gonna make total bigger. Right, so here I'm just gonna say total is equal to total plus something, right, plus line. If anything, this line needs to be converted to a number because it's a string. So we don't want to concatenate strings. We want to convert it to a number, properly add it. Okay, let's try this out. So press play. There you go. I loaded it in. And then let me rerun this local test case. Hopefully it prints true and false again. So, okay, cool. Prints true and false. And let me check the checker, see if it's good. Sweet. Yeah, we're all good. Okay, cool. So we just wrote a kind of a more general solution. If we were to work with this one, right? This one is saying the file will have 4 numbers on separate lines. You probably want to be careful with this because in a future class, they're gonna throw different size files at you. So this question, solution, is still assuming there's 4 numbers in a line. If there are more numbers in the line, it's actually gonna look at all of the lines. So if you want to add in some protection, right, you can put in some protection here. Like you could do something like make sure this for loop only happens 4 times. Right? Like here, you don't have to do this. There's so many different ways. Let's see. I could make a variable that represents how many times we did it. Like we could say iterations equals 0, and then you could say something like every time we add a number, then increment the iterations. And then once we get to 4, then we can break. Right? If iterations equals to 4, then a break. And this is like a kind of like a protection. It's making sure that we only sum up the first 4 numbers. Okay, so this is kind of overkill for our solution. But yeah, I just want to let folks know that in a future class, you're gonna have to kind of write protective functions. Okay, let me make sure this still works. Okay, cool, still works. Okay, let's move on to the next questions. Okay, let me comment this out because we're done with it. Okay, the next question was asking us to do a HTML hyperlink. We're supposed to take in a plain text as a first argument, and then an address as a second argument, and generate a HTML string, or an HTML string that represents something called an A tag. So you have to go to the previous lesson for this. Once again, during the exam, during the actual final, it's open book. So you can go through all your previous lessons. You can Google stuff. but the lessons might have most of the info. So we're going to do something called an A tag, which is a hyperlink. It pretty much looks like this, right? This is an A tag. The A tag, we have the URL as something inside the opening tag, and then we have the plain text between the open and closing tag. So we're going to do something similar to that. We have a test case here. Let me uncomment it. Now, this test case is saying, hey, call the function. The plain text will be course home, and it should link. If we were to click course home, it should link to over here, this website. I think this is our Python website. Okay, so let's see where we left off at. Oh, here it is. Yeah, link target. Okay, let me uncomment this. We left off at the skeleton that returns an empty string. All we need to do now is generate this my HTML string. It needs to contain the A tag. Right, so kind of, it needs to contain something like this right here, right? A opening A and then a closing A. So let's go ahead and apply that. Basically, the HTML string needs to have an opening tag A and a closing tag A. Right, so the plain text goes between the tags. In this case, the text is represented by this argument, text. So I'm going to put text in here, but as an F string. So I'm going to prefix this double quote with an F, meaning that we're going to interpolate the string into it. Okay, cool. We got the plain text. The next part is to use the URL and have this text point to it. The way we do that is kind of in the, let me look at the previous lesson. Okay, so it looks like the URL goes in the opening tag. All right, a href is equal to a string of the URL. It looks like we're going to have to use another type of quote because the hyperlink reference is using double quotes. So here's what I mean. Right, but basically, we're going to have to convert these to a different type of quote because we're going to end up doing a href is equal to a double quote, and then the URL in here. But we're going to have to convert to a different quote because now it's going to end here, and then Python will think it's going to give us some sort of unterminated string literal. Maybe I could use a single quote instead. So let me use a single quote on the outer side, and then there we go. Cool, so href is equal to a quote, and inside of it is going to be the URL. Okay, so let me run this. Okay, there we go. I just pressed Control Enter. The one thing that's really annoying is every time I press play, it just kind of jumps to a different spot on the web page. I wish I could press play and it would just stay in the same location. There's probably some setting for it. I gotta play around with it. Okay. So I just loaded this function in. Let me test it locally. Okay, let me print this. And yeah, it's giving us a tag, right? This is a representation of it. Right? It's not really the actual rendered HTML yet. Right? This is a raw HTML string, which makes sense because the whole goal of the function was to return an HTML string. It's probably the caller's job to convert this instead. So we could actually, instead of printing the raw HTML text, right here, let me get rid of this raw HTML text. print statement. So I just got rid of the print statement and the parentheses. We need to convert this to an HTML object and display it in order to render it. So you might remember that in a previous lesson, we had to import something. Let me go to the top here. There it is. We had to import this library, which lets us use HTML objects, which will also let us render it. So in the test cell, I'm just gonna import that. It's probably the caller's job to convert it, and the caller here is the test cell. So I'm gonna go ahead and convert this to an HTML object, and then also display that object. So display and run. Okay, cool. Just ran it, and there we go. It rendered our HTML string. Right, the plain text is course home, and then this one is. If I click it, it's going to lead us to that URL. Okay. Are people cool with this so far? All right. Okay, cool. We're done with this. I'm going to comment that out. So display, comment that out. Okay, let's move on to the next question. Okay. Squeeze this in. Okay, a couple more to go. Okay. Question 4. Write a function to print contact info from a dictionary. Okay. We set up a test case here at the bottom of this test cell. So let me uncomment it. Basically, all this test case does is hard codes a dictionary and then passes that hard-coded dictionary into the function that we need to write. And so this hard-coded test dictionary can be anything. You can write whatever you want, as long as it has the right keys. But if we were to pass this dictionary into the function, it should produce output that looks like this. So this function is actually technically called a void function. I don't think you'll hear about what voids are until a future class, but void functions are functions that don't return anything. It just does something with it, right? You pass input in, it's not going to return anything. It's just going to do something with it. In this case, it's just going to print information from that dictionary. And it needs to be formatted like so, right here. Okay. So let me see where we left off at. Okay. Oh, we don't have anything here. Cool, so let's go ahead and get it started. So the name of this function should be print contact info. Make sure that the definition is spelled correctly, by the way, because the checker will rely on the correct naming. So this is a function called print contact info. Okay, let me put a doc string in here. Oh, I mean the input. Right, so the input or parameters is a contact. All right, let me go ahead and describe what this function does. Okay, so all this function does, right, the whole purpose of it is print info from a dictionary, from a contacts dictionary. Yeah, that's the whole purpose of it. There's only one argument here. It's contacts, singular, contact, which is a dictionary containing name, containing the keys, name, address, phone. Okay, there's no return value here. It's a void function. All it does is take the input dump stuff out. Cool, so let's get it started. For the sake of this problem, this question, we're assuming that the dictionary has those 3 keys. So we can just print the values associated with those keys. Let's go ahead and print this first line. The first line is accessing the name key. So let me go ahead and print the first line. So print, okay. Right, we need to print this first part. Right? The easiest way is you can just say name, because we're assuming that the dictionary will have that name key. And the next part will be the value associated with that. So we could probably use an F string here to be a little cleaner. Right? Like, let me convert this to an F string, meaning we can interpolate a value into this. Right? And in this case, we're just going to interpolate the name. So this is saying grab the value associated with that name. Okay, let me test this real quick before we do the next lines. Let me load this function in. Okay, I just press Control Enter, which loads it. Okay, let me test it locally. Hopefully it prints that. Let me put my name here actually. Andrew Tack. Okay, and then Control Enter. Sweet. All right, so we hard coded a dictionary, passed it into here, and yeah, it's printing out the first line correctly. All we need to do now is print out these next key value pairs with a indent, a tab character. Okay, so let's go ahead and go up. Print, we need 2 more print statements, right? The next one will be the address. So let me do the same exact thing, right? Address, and then interpolate the dictionary value. Okay, there we go. There needs to be a tab character, and there's multiple ways you can do this. You know, you can do an escape character, right? Escape T. You might remember this from a previous lesson. It's an escape character puts a special sequence in your string. So yeah, this is just a tab. Right, it's like you might remember new line, right? /n. This is just it goes to the next line, but we're gonna do a T here, and then same with the next one. The phone. Right, so a tab character, phone, and then the contact. I gotta use single quotes there, and then phone. Okay, cool. Let's run this. Control Enter. There we go, and it jumped to a different spot for some reason. Okay, I got an error here. This is actually a very common error. It looks like mismatching parentheses or something. So let's see what happened. Let me just double check this. So the key is in a square bracket. This one doesn't have an ending brace. So that ending brace goes here. Okay, cool. Let me run it again. Okay, cool. No more errors. All right, let's test it locally. So boom, print contact info, and then there we go. Yeah, it looks good. It looks like here the tab character has more than 4 spaces, but yeah, you don't really have to worry about it because this is technically a tab character. See how I highlight it? Right, I'm highlighting right now, and then boom, right, that's a whole tab. Okay. It doesn't really do something like this, where it's like 4 spaces, like 1, 2, 3, 4, right? It doesn't do that. Just like, see, it doesn't really. Yeah. Okay, let's move on to the checker. Let me run this, Control Enter. And yeah, it looks like we're good. Print contact info. This checker didn't really test everything, so it's possible for the solution to be incorrect but the checker will still say it's right. But basically, I'm saying it's possible for the checker to produce false positives. But we verified it's not a false positive with the local testing. All right. People cool with this so far? All right. Let's move on to the last one. The last one. The last one is asking us to create a class called counter. We already did this a week ago, so I'm pretty much going to refer to that. So let's see. On the very last lab, see, yeah, we wrote a counting class, which is like a tally counter. It's you can imagine it as an object that has the ability to increment and decrement. So tally counter. Let me look at a different picture. Yeah, imagine something like this, but with a reset button. The reason why I'm saying reset, oh, it looks like there is a reset button on top. Okay, yeah, so imagine something like this, right? There's a plus button, a minus button, and a reset on top. And that's kind of what we're implementing here. Right? We have a function here called the initializer. This is a constructor, right? All it does is spawns a counter. And then we have another function here, -1. Right? This is the decrementer, this subtracts. Got +1, and then a reset count. A reset count is a function that just sets it back to 0. It's over here. So yeah, we kind of did this. If anything, our previous lab didn't really do that reset function. But yeah, we can go ahead and do that. Okay, so let's go to the over here. Okay, let me comment out this previous test case. Okay. Let's see. Okay, so write a class called counter. And then it's going to have 2 attributes. The first attribute is the current count, and then the next attribute is the initial count. Okay, cool. Let's get that then. Yeah. Okay. Class counter. Cool. So we have it over here set up. Class counter. Put a quick doctrine in here. I'm just gonna say represents a tally counter. I'm not really sure what it's called, but yeah, it seems like tally counter is the name for it. Okay. One of the first functions that we should do in a class is the constructor, which is a function that will initialize all of the elements in the class. So please review the classes lessons. I think we spent 2 solid days on it. Yeah, please review those stuff. So let's get the constructor. So define a constructor. Careful with these indents. Right? We need to have an indent here so we can signify that the functions belong inside of the counter. So define a constructor, which is 2 underscores, init 2 underscores. This is just the Python syntax. Whoever invented Python classes, they decided to name their constructor like this. It's just a special function. This function is going to have two arguments, but it's really the second argument that matters. And remember, self is like a special argument. It's not really not really used when we call it. So yeah, self, and then another argument called start num. Basically, the constructor is supposed to use the start number and initialize its attributes to that. So that's where we see on the top over here. Right? It's saying we have an attribute called a count, and then another attribute called the initial count. Initial count means we're keeping track of what we spawned the counter with. Right? So in this case, our counter is spawning, right? Initial count. It's spawning with the start number. Okay. We also have to initialize another attribute, the current count. So let me do that. So self.count is equal to the current count. In this case, when we spawn a counter with a start number, it should also be the same. So you could say self.count is equal to initial count, right? Or you could say is equal to start number. Same thing. Okay. Let's test this real quick. Right, so before we move on to the next functions, let's make sure that this initializer is working correctly, this constructor. So here, let me just comment this real quick. Let me see. I don't think you really need a docstring for these. It might be a little overkill, but I'll put it in here anyways, just in case folks are not sure what this does. Right, this is just a, I'm going to keep it on one line. This is called an overloaded constructor. Okay. They call it overloaded constructor in other languages too. Okay. They call it overloaded because normal default constructors don't have this second argument here. And the overloaded constructor has an additional argument. Okay, let's test this constructor. So let me run this cell. Okay, cool. It brought me to another place. Okay, cool. I just ran it. Let's test the constructor, right? The way we do that is by spawning one. So we can spawn it by saying something like something is equal to counter. Right? So the left side, it doesn't really matter. I'm going to call it like tally. Right? So tally is the name of the object, and we're going to pull it from the counter class. Right? And then make sure that the right side has two parentheses. Otherwise, it's not really going to call the constructor function. So yeah, this line right here, once again, you have to look at the previous lesson. So I'm so sorry if I'm repeating myself too much. But yeah, this left side, this name doesn't matter. We're just creating an object name, which comes from the cookie cutter counter. A cookie cutter is a class. Okay, so let's test this, right? Once again, this is not gonna work because we didn't call our constructor correctly. It's saying the constructor is missing one more argument, right? The start number. This is because this line is calling a default constructor, which we don't have. A default constructor only has a self argument in here, right? But since we have another argument, we got to put in a number. So let me put in a number here. Like, let's say we spawn a tally with the number 6. It doesn't really matter. This is saying when we create a tally, it should start at 6. Okay, so let's run it. So press play. Okay, cool. I just pressed play, and I got an error here. Okay, so that should have worked, but we got an error. It's saying name start number is not defined. Yeah, so let's go up to that line. Let's go up to the class and see what's going on. It's pointing at our class constructor. Okay, it's saying this is not defined. Yeah, that makes sense because we spelled it wrong. So let me rename it. There we go. Start num. There we go. Okay, run that. Go to bottom. Run this. Run. Okay, cool. No more errors. We successfully constructed an object. Right, so let me just comment this. This is constructing a counter called tally. Okay, starts at 6. Initializes to 6. Okay, let's verify that the constructor did initialize the attributes correctly. The attributes for this counter class is self.count, right? That's one of them. This keeps track of the current count, meaning that if I were to access the tally.count, right, it should print 6. So let me print it. Hopefully it prints 6. Okay, cool. I just ran it. Yeah, it's printing 6. Perfect. Okay, hopefully that makes sense so far. We're just sanity checking our constructor. And there's also another attribute called initial count, which should be 6 as well. The reason why we have this redundant initial count variable is because one of the next functions will reset the counter, and I think it's going to ask us to reset the counter to whatever the initial one was. Right, so reset in this case doesn't really mean reset it to 0. It probably means reset it to whatever we spawned it with. Okay, so anyways, let's move on. We got the constructor. Let's move on to the decrementer, right, -1. So let me go up here. We got to define another function. Please be careful of your indents again. 4 spaces here. Right, there's a function called -1. Okay, it takes in. All it's going to do is subtract 1 from the counter. Right? So we have an attribute called count. So all we really need to do is access that count and set it to 1 lower. There we go. It sets one lower. Okay. Yeah, well, once again, this is stuff from over here. So I think folks have already seen this stuff. Okay, so -1. Let me test it real quick before we move on to the +1. It's really good programming practice. Keep testing. If you don't test frequently, you're going to get a bunch of errors. It's possible to get a bunch of errors at the end. Okay, let's test the -1. So tally.-1. I'm just going to do it twice. Okay, this is saying we spawn a tally starting at 6. Okay, press the minus button twice, and hopefully it prints out 4. So let me run it. Control Enter. There we go. Yeah, it's printing 4. Cool, looking good. Let's move on to the next ones, the opposite of -1. So the next one is +1, right over here. So let me define something called +1. Okay, and here we're just gonna do the same exact thing, right? Just opposite. Access its current count and set it to 1 bigger. All right, let's run this and test it. Okay, let's test it down here. So let me +1 again. Tally that +1. I'm just gonna do it once. It should print 5. I get 6 -1, 5, and then this becomes 4, and add 1, this should become 5. Cool, so let me test it. So Control Enter, and then 5. Cool, looks good. It looks like our +1 function is working. Finally, there is a reset counter function, which resets it. I think some folks might set it to 0, but it's going to ask us to set it to the initializer instead. So here, you know what? Let's see. Yeah, let's go ahead and implement this reset counter function. All right. There goes my projectors. Okay. Give me 1 second, folks. My projectors are flickering. Okay. Cool. Projectors are back on. All right, let's make a function called reset count. So define reset count. It's called self. Okay, so a common pitfall here is we might set it to 0. So let's try that. All right, let's just say self.count is equal to 0. And let's just see what the checker will say. Okay, sorry, my projectors are flickering again. So I'll have to pause real quick. Sorry about that, George. Yeah. Recording should be fine though. Okay, cool. So we got the reset count. Let me go ahead and test it at the bottom. Like if we were to reset it here, tally.reset, it's going to set it back to 0, meaning it's just going to print 0. Let me run it. Oh, okay, reset. Has no attribute reset. This is probably because I named it wrong. So reset count. Here we go. Oh, still has no attribute. So maybe I didn't run the cell above. So let me run this cell above here. So run. Run. There we go. Cool. It's printing a 0 now. Let me just check the checker to see what's going on. Let me run this. Yeah, it looks like our reset isn't really working as intended. It says reason. The count is not correct after calling a reset count. Meaning that a reset button was meant to set it to whatever we initialize it with. And our class does keep track of this as an attribute. One of the attributes is initial count. Right? It will store the initial count that we spawned it with. So here, instead of setting it to 0, you can just set it to self.initial count. Right, this means run this. This means that this local testing here should print 6. It doesn't matter what we do in here. It really doesn't matter what we do in here because we're resetting it to the initial 6. So let me press play, and there we go. Right, it prints 6. And let's check the checker now. Cool. Yeah, we're all good there. Right, we passed the class counter. Hopefully people are cool with this so far. So we're probably ready to submit. It's going to be like this. Right, copy this whole class and then paste it into here, the canvas. So paste, and let me pre-format everything. Pre-format, there we go. Cool, I think we're done with the exam. The last question is asking us to upload the notebook. Let me see if I have it here. Yeah, upload the notebook. Please be careful about this question because some folks submit empty notebooks. I think it's because they have multiple copies of the same file and they end up submitting the empty copy instead. So yeah, when you're submitting, please be careful about this. You're going to want to update. You're going to want to download the file from Jupyter first. Right? Like on the right, you're going to want to download it. However you download it. I'm not sure how folks here download it, but I think some folks do it like this. So some folks would right click the file and then click on download, and then some folks would go on here and then go download. There's multiple ways. Either way, when you download it, make sure that file is uploaded to this canvas here. Right, but please don't. It's very easy to upload an incorrect file. Oh yeah, yeah, yeah. George in class mentioned that we should also save frequently. So yeah, you can hit Control S, which will save it, or you can click on some save button here. Yeah, thanks for mentioning that. Yeah, totally need to save it too. All right. Well, this was good timing. So my projectors finally failed, but yeah, we finished all of this stuff. I hope this gives folks a good head start on the final exam. Uh, if this is insufficient, if some folks might be super comfortable with this material already, um, and if you're moving on to the next class, I would recommend some more practice. I pulled this up last class, so you can just Google up something like Python function practice. Python function practice, and then let me just click on this W3 resource. This is a secondary resource. I pointed out that the first 10 are good practice for this class. Right, for if you need more practice on the final exam, I would do 1 all the way to 10 down here. Print even numbers. And then these next ones, everything after 10, this is for folks who are kind of moving on into the next class. People going on to, I think it's called CS20P, the Python programming. Okay. Cool. Yeah, so just to repeat some final announcements. Our final exam is on Friday, on the May 30th. If folks have a graduation walk on that day, please let me know so we can reschedule for a different time. Okay. Yeah, George. Say that again. Oh yeah. As for previous work, yeah, you can always still turn in the assignment as many times as you like. Yeah. Okay. Cool. Thank you all for coming, and hope you all have a good weekend.